Hello everyone. So I'll be taking next 15 minutes of your time to take you to this exciting journey of Ross and Isaacson and how it is a powerful tandem for swarm robotics. So allow me to introduce myself. I'm Kartik Soni. I'm an executive robotics engineer at RigBetel Labs. I majorly work on embedded and Ross systems there. The result of which I get to work on so many cool projects, including AMRs to drones to manipulators and legged robots and whatnot. Also, I am a huge Bollywood biggie, so I like to spend my spare time to fulfill my Bollywood dreams. So yeah, here's just an example of it. Coming to us at RigBetel Labs, I think you know enough about us already. I just want to add that we are an organization that are always on the lookout to create innovative solutions for the robotic community. So one such problem we came across is flexibility in fleet management. I'll explain you what this means. Coming to case one, Case one is a general AMR. Let's say there's an AMR which is compact in size. It is very easy to deploy and maintain, but it has limitations to the payload lifting capacity. Whereas there is a case two where there are heavy duty AMRs which have high payload carrying capacity, but they have a bulky form factor and they are not very easy to deploy and maintain and all those things. So what if you are a dark warehouse owner and it is like you are comfortable with using general sized AMRs, but there are times where the packages are large enough or the payloads are heavy enough that you have to take bigger AMRs. So what to do when you don't have them? There's a solution for that. What if there's a method to achieve small compact form factor, a system that is easy to deploy and maintain? It has dynamic robot footprint, and all of this comes with a customizable payload capacity also. So allow me to introduce you to collaborative AMRs, the technology that we've been working on, which will make you rethink what AMRs can do for you. The idea is pretty simple to its root level. Instead of using one large sized AMR, you use multiple small sized AMRs in a formation so that they work together and work like a large sized AMR for you. So it's similar to multiple people lifting a heavy payload. You use multiple robots to lift payloads for you. Here are some of the features of collaborative AMRs. Firstly, it is completely adaptive to the user. So you as a user has to decide the number of robots you want, the number of the kind of payloads you want to lift, and the kind of formations you want to make. It's completely up to you. Let's take a deeper view into the functioning of these AMRs. Coming to the mechanics of it, allow me to introduce you to our very old friend Cepheus. I think you might have met Cepheus in our stalls already. So it is an omniwheel mechanism-based robot which can move in all the four directions. It is quite a fancy robot, I must say. It has max speeds of up to 0.6 meters per second with a payload capacity of 120 kgs. And all of this comes under a very slim and compact design, which is perfect for collaborative AMR technology. Next is the ROS packages for it. I'll take you through the flow of it. So on the upper end, as a user, you don't have to do much things. You just have to say what kind of payload you want and what is the formation you want to make with your AMRs, and all the other things, all the mathematics and calculations will be carried out by the package itself. And finally, there are pure velocity values coming out of it, which your AMRs can directly use. So let's, enough of the explanations. Let's see the real robot deployment of these robots. So we have two Cepheuses at our place, which we will use to elaborate the technology. So as you can see, both the AMRs are working together. They can move diagonally, forward, backwards, they can rotate in place. And since you don't have any restrictions on formations, you can make whatever formations you want depending upon your payloads. Yes, this was a simple implementation that we just conveyed to you. Now, doing these kind of testings is a different thing, but while we are creating the packages, it is not always feasible for us to directly deploy it on a real robot. So simulations are really important while we are working on robots, right? So we needed a system that is stable enough and realistic enough to do these kind of simulations for us. So introducing Isaac Sim for you. Now, my colleague, Mr. Sanket Khade, will continue on this. He's an expert on NVIDIA Isaac Sim.
So, hello everyone. My name is Sanket Khade, an executive robotics engineer at RigBetel Labs. I primarily work on the ROS2 simulations. I use the simulation tools like Gazebo, VBots, and NVIDIA Isaac Sim Unity. So, just tell me how many of you know about the NVIDIA Isaac Sim? Just raise your hands. And how many of you use it in actual? There are very few people who use it in actual. Okay. So this is the one demonstration of the PrototypeBot Pro Max, the robot by RigBetel Labs, and this is the office of the RigBetel Labs. It is a complete digital twin created in the Isaac Sim. You can see the realisticness of the environment, the lights, the flow of. So Isaac Sim is an NVIDIA platform for the robotic simulation. So there are multiple platforms available like Gazebo, Unity, VBots. So then why Isaac Sim? You can create a custom solution. You can create a photorealistic and physics realistic simulation to reduce the sim to real gap. Along with the current trend in technology like the synthetic data generation also possible in the Isaac Sim. I told about the reducing the gap between sim to real. So these are the two pictures. One is the real robot and another is the simulation. You can see, you can find that due to the use of that first robot, it is a bit realistic visible, but this is the second one is a simulation. This is how you can create a realistic simulation in an Isaac Sim. So talking about the controlling robot in the Isaac Sim, there are multiple methods to program a robot in Isaac Sim, like the Python scripting, the visual scripting. This is just one example of the visual scripting. This is how you can control the differential drive robot in the Isaac Sim through the command velocity published by the ROS. With the small changes in this graph, you can adapt it for the four-wheel drive robot also. Talking about the mechanism wheels, in the community also I face that many people struggling making the mechanism wheel physics in the Isaac Sim. Talking about the physics, the custom colliders are required for the rollers of the mechanism wheels. As you can see, these greens are the colliders for the mechanism wheels. So it is a bit trickier to create an custom colliders for the colliders for the rollers in the mechanism wheels. So we came up with the idea like many of you use the planner plugin in the planner plugin in the Gazebo, I guess. So this graph will act like a planner plugin in the Isaac Sim. You can take picture for the reference because the many people are struggling for the mechanism wheel simulation in the Isaac Sim. So this will allow you to reduce your time on Isaac Sim. Okay. So as Kartik told about this multiple formations of a robot, these are some of the example of spawning the robot in the Isaac Sim. Currently, we are using the ROS param to spawn a robot in Isaac Sim, but also we are working on the GUI to spawn a robot according to the payload capacity as well as collaborative platform size. That's how it can be modified. And this is one the demonstration of the collaborative platform. You can see the you can see the multiple formation. That the one is the single robot. These are the 3 robots. These are the 5 robots doing the work in the Isaac Sim. As Record also mentioned about the fleet management and the swarm, this is also one example for the swarm robotics. And I believe that the simulation can reduce your development time on the real robot and the mobility of the robot. So you can create an custom physically accurate model in the Isaac Sim and implement your algorithm there to reduce the sim to real gap. Okay, that's it from my side. Thank you for everyone. These are 2 LinkedIns, Maya and Kartik. So you can connect with us for the review. Thank you.
Yeah, if you guys have any question, we can take one question and then we can take a break for lunch. So are there any questions for Kartik or Sanket? Okay, there is one person over there.
Great work actually. Quite impressed. The thing is I wanted to ask is as you are using multiple robots, so in simulation, okay, that works pretty well. Like 4 robots are there, all are rotating at same speed, moving at same speed. But when things come to the real life, every robot have its own wear and tears, right? So how you guys are handling those things?
So currently, there are multiple localization packages that are running in the background. Like
Okay.
the CFS that you just saw, it has encoders and IMU and all those things that are doing all the localization thing for you. And apart from that, there is also one thing. There are also like both the robots are collaborating with one another to just understand where they are, and they can just they can plan accordingly. And if there are certain errors in the movement, they can adjust themselves only. So that
Okay.
is the plan we are
So they
working.
can compensate for the
They can
others' error.
compensate for all the errors.
That's great.
Yes.
Thank you.